Dr. Cannon, thanks very much for accepting our invitation. It's always a pleasure seeing you. See, in thinking about the field of metabolism, I think that the two biggest findings over the past, say, 5 years have been, to me, the effect of bariatric surgery in diabetes. But the other one is certainly the discovery of brown fat in people, and there has been a lot of interest about it in terms of its ability to dissipate energy, and the people thinking about the therapeutic implications of such a discovery. And if one thinks about the life cycle of many of these discoveries, we start with the observation, then there's a lot of hype, then we get to a phase of disappointment, and then to a phase of more stability. So in the case of the field of brown fat, are we still in the hype phase, or are we now more in the disappointment phase, or where are we?
I think, well, this is the second hype phase of brown fat. Brown fat was hyped in the 80s as well as an anti-obesity treatment. But then people didn't really believe it was present in adult humans and therefore didn't have a metabolic effect. But there was a huge hype even then. Now the new hype has come, and I think we're probably just over the crest of the wave at the moment, but we haven't gone down into the valley yet.
Yeah. So what sort of things are necessary to discover now so that we stay in the hype phase as opposed to going down into the disappointment phase? Because normally the sort of things that push fields in the disappointment area are, oh well, in the end it's going to be very difficult technically to take advantage of brown fat, or it's actually much more complex than we thought, or there isn't enough in people, etc., etc. But how can we prevent from the disappointment phase to settle? What sort of findings are we looking for now that will maintain its high priority?
I think that one of the most important aspects is a technical aspect, and that is to be able to identify it in adult humans without exposing them to high doses of radioactivity, because this limits our ability to do experiments. And if you can't do experiments, if you can't do a series of studies where you actually give people drugs or expose them to cold or do different treatments and measure before and afterwards, then we're in a much more limited situation. And at the moment, many countries, including Sweden, do not allow 2 PET scans on healthy subjects. So you can only do 1. So you can identify that you have or don't have brown fat, but you can't do a post-treatment study as well. So NIH particularly are supporting 2 large projects at the moment to try to develop techniques that can reliably identify brown fat without exposing people to high radioactivity. And these involve thermography or MRI. And at the moment I'm only modestly optimistic that these will work in a reliable way, because they all build on how much lipid there is in the tissue. And while this is easily done in animals, it's not so easy to identify in humans, because there the small areas, the islands of brown fat, are embedded in white fat. So to find this little area accurately and to quantify all of these little areas, I think is difficult. But I'm going to an NIH meeting at the end of this month where this will be ventilated, and we'll discuss what's ongoing here.
But it sounds quite interesting to me that the alternatives that you're exploring are also imaging alternatives, as opposed to looking for other kinds of biomarkers. Yes. And that's because we care about the exact place where it is. So it's not only good enough to know that we have it, but we need to know where it is.
This is also an aspect people are starting to look at. Is there anything in our circulation any factor which is secreted selectively by brown fat, as opposed to all the adipokines that we know white fat secretes. And we are several groups who've worked for several years looking for a selective marker here, and so far this hasn't been identified. So people are now starting to look, are there anything in exosomes, for example, of people who have brown fat? Is some mRNA for our signature protein UCP1? Can this be found in circulating exosomes? So we're collaborating with a group in Belgium looking for this at the moment, and this project is a collaboration also with a group from the University of California, Davis, who want to try and identify this in humans, because of course I admittedly mainly work with mice, and I can cure obesity in mice better than I can do in humans at the moment.
Yeah, that's not unusual to see. We've cured so many diseases in mice. Another thing that and in fact very connected to what we're discussing in the field of brown fat is some people have called the phenomenon of beiging. Right? Beiging the white fat so it becomes more brown. And in that case, of course, what we know about the biology of the brown fat will guide a lot of this effort. But do you think that it really is a therapeutic avenue that will bear fruit from the therapeutic point of view? I think that biologically it will be very interesting to understand the relationship between the two types of fat and what makes one, what makes the other. But therapeutically, is it something that can really be harnessed? And what sort of thing we would have to develop for that?
At the moment, my personal view is that I think it would be more appropriate to develop something for activating brown fat. But it's an attractive conceptual model to think of developing a little furnace within your white fat depots and burning them in situ. I think that there's an appeal about this. We've calculated doing extensive total balance sheets that in mice anyway, I have to again refer to mice because we have no other data, the beige adipose tissue can contribute only between 10 or in certain mouse strains up to maybe 25 to 30% of the contribution of brown fat, even though it's a very much larger tissue, simply because there are fewer mitochondria and so on. And this is why we think brown fat is more appropriate. However, because we also know that the cells have a different progenitor than the brown fat cells, it is conceptually possible to say that, okay, these beige cells have some different receptors, and therefore we could target these with a more appropriate compound than we can the brown. We have no idea about this at the moment, but it's a theoretical possibility. And then we could use this because, of course, if I can elevate my energy expenditure by 10% a day, I would become slim if I didn't eat to compensate over a long period of time. I don't think this is a quick fix. This would be a long-term body weight maintenance.
Okay, but that's not bad. That would be
so,
quite welcome.
I mean, ideally, I think what we should aim at is keeping people's brown fat active rather than trying to reactivate it. That we should try to keep people in a situation that they have as much brown fat as they have when they're in their 20s, also when they're in their 50s.
So how much do we know about the developmental changes that happen to brown fat? So everybody in their 20s has
Yes.
brown fat, and then it just...
It fades.
It fades.
Yeah. We don't know enough, again, because of the inability to identify it easily in people. So the earliest reports that were based only on looking in hospital archives at old PET scans gave an underestimate because PET scans only show brown fat when the tissue is actually active. i.e. when you're cold. So if you're in a warm room when you're scanned, even if you have brown fat, it won't be visible. So you have to do real experiments, make people feel cold, and then you can light up the brown fat. Where was I going? Sorry.
We were talking about the developmental aspects. So then young people, there has been.
I believe that from the limited amount of data out there, all people up to the age of 30 have brown fat, probably in varying amounts. And then after this, it starts to decrease. However, I think even in their 50s, people still have stem cells, brown fat. So if you could find something to tickle them, to activate them again, a sufficient sympathetic drive, for example, then you could redevelop brown fat. Developmentally, we know that if we study brown fat in aging in rats or mice, they also lose their brown fat. And they don't sit and watch television and they do their thing at all ages. And so I'm only modestly convinced that lack of exercise is the reason for our obesity at the moment. I think our food intake patterns are a much worse problem. But we know that rats, their brown fat declines in just the same way as we believe it does in humans from the small amount of data that's present. And if we put an old rat in the cold again, it will get back some brown fat, not as much as it had as a young guy, but it'll get back some. And this is why we think that it is still possible. We probably lose stem cells, but there are probably a few around.
Yeah, it'll be very interesting to find them and to be able to manipulate them.
Yes.
That's
this would be
so that's very interesting. So there are different ways in which one can really get the brown fat to have more beneficial effect, and
it has to be, I should emphasize, a two-component drug or whatever we're aiming for, because we need in most people to make more brown fat. That's one thing, but we also have to have it constantly active, because it can sit there, and if it's not turned on, nothing happens. Yeah. And so it's not good enough, as many drug companies think at the moment, just to make more brown fat. You have to have this potential to switch it on and keep it on. And this is why I think it's a huge challenge, because any drug or drugs that are going to do this have to live up to a safety level for a lifelong treatment.
That's correct, yeah. With some of the speakers at the event in the afternoon, some of the things we were discussing was how difficult it is to develop new treatments for the metabolic syndrome because of safety concerns. That's not going to be different in this case.
No, absolutely not. It's the same concern.
Well, thank you once again for agreeing to come to this event, and I look forward to your talk in the evening.
Thank you. It's my pleasure. Thank you.